Find the normalization constant n over the interval negative a to positive a for a given wave function psi of x equal nx into bracket a squared minus x squared. The question indicated that n is our normalization constant here. In this case, the normalization constant has already been included in the wave function. We just have to solve and look for its value. Normalization constant, to solve it, we are going to take integral from negative a to positive a, the limit given to us. Absolute square of psi of x squared. The x, since it is in terms of x, equal 1. And we know that psi of x is the same as this whole thing here. So we just take integral from negative a to positive a, absolute square of everything here. So nx into bracket a squared minus x squared into bracket absolute to the square. The x equal 1. So we can go ahead and simplify whatever is under the absolute sign. So n squared, n to the power 2, n to the power 2. So integral from negative a to positive a, n squared, then x to the power 2 gives us x squared, and this whole term multiplying, raising to the power 2. So a squared minus x squared all to the power 2, the x equal 1. And since n is a constant, we can factor it out. So n squared integral from negative a to positive a, x squared into bracket a squared minus x squared all to the power 2, the x equal 1. If we have from basic mathematics a minus b to the power 2, and we want to simplify this, first of all, we square the first term, which is a squared, then multiply the power by both terms. So 2 multiplied by a multiplied by minus b is going to give us minus 2ab. Then squaring the last term, which is b to the power 2. So let's apply this idea here. So we are going to get n squared integral from negative a to positive a, x squared into bracket. So a to the power 2 to the power 2 again gives us a to the power 4. Then 2 multiplied by a squared multiplied by minus x squared gives us minus 2a squared. Sorry, minus 2a squared x squared. And now we square the last term, x squared to the power 2 gives us positive x to the power 4. Then the x equal 1. Now let's expand the bracket. So n to the power 2 integral from negative a to positive a. We want to expand the bracket. So x multiplied by a to the power 4 gives us a to the power 4 x squared multiplied by 2 to the 2a to the power 2 x to the power 2 gives us minus 2a to the power 2 x to the power 2 multiply x to the power 2. Since they are of the same basis, we add their powers, giving us 4. So x squared multiplied by x to the power 4 plus positive x to the power 4 gives us x to the power 6. Since they are of the same basis, we add their powers. Then the x equal 1. The next thing we want to do is to integrate the whole thing with respect to x. Then if we have x to the power n and I'm integrating with respect to x, it's going to be x to the power n plus 1 all divided by n plus 1. So let's do that. So integrating x to the power 2 with respect to x is going to give me x, the power increase by 1, which will give me x to the power 3. Then I'll divide everything by 3. So let's apply the same idea here. So we are integrating n to the power 2. So we are integrating with respect to x. So wherever we see x, we integrate. So we are going to have a to the power 4, x to the power 2, integrating will be x to the power 2 plus 1, giving us x to the power 3, and divide everything by 3, minus 2 a to the power 2, x to the power 4 gives us x to the power 5 all over 5, plus x to the power 6, integrating gives us x to the power 7 all over 7. Now let's indicate our integration limit. Minus a to positive a should be equal to 1. So now m to the power 2, we first put in the upper limit. So wherever we see x, we replace it by positive a. So a to the power 4, x to the power 3 becomes a to the power 3 all over 3. Minus 2a to the power 2, x to the power 5 becomes a to the power 5 all over 5. X to the power 7 becomes e to the power 7 all over 7 into bracket. Then minus, we now put in the lower limit. Wherever we see x, we put in minus a there. So a to the power 4 and then minus e, x to the power 3 minus e to the power 3 all over 3. So minus 2e to the power 2. So x to the power 5 becomes minus e to the power 5 all over 5. Then plus x to the power 7 becomes minus e to the power 7 all over 7, all in bracket, equal 1. So let's shift it here. Let me shift this whole thing here. So we are going to get n squared. Let's simplify whatever is in the bracket. So e to the power 4 multiply e to the power 3. Since they are of the same basis, we add their power. So e to the power 4 plus 3 gives us 7 over 3 minus 2a to the power 2 multiply a to the power 5. 2a to the power 7 all over 5 plus a to the power 7 over 7 minus, let's simplify this term here. So a to the power 4 multiply minus a to the power 3. Since the power of minus a is an odd number, the negative sign will affect this. So this whole thing becomes minus a to the power 7 becomes minus a to the power 7 over 3. We have minus a to the power 5 here. Since the power is an odd number, it will affect it. So we are still going to get minus going to give us plus 2a to the power 7 all over 5. And here we have minus a to the power 7. Since the power is an odd number, it's going to give us minus a to the power 7 over 7. Then all equal 1. So let's simplify everything. We are going to get n to the power 2, a to the power 7 over, is this 3 or 9? 3, right? 3 minus 2a to the power 7 over 5 plus a to the power 7 over 7. 7 minus minus gives us plus a to the power 7 over 3 minus multiply by positive 2a to the power 7 will give us minus 2a to the power 7 all over 5 minus multiply by minus a to the power 7 over 7 gives us positive a to the power 7 over 7. Then bracket all equal 1. Now, is there any cancellation that we can do? So we have like terms here, a to the power 7 over 3, and then a to the power 7 over 3. So adding the coefficient, we have one of them here, and one of them here. So it becomes 2a to the power 2a to the power 7 over 3. It's more like taking the coefficient. Here is 1 over 3 plus 1 over 3, and they are all multiplying a to the power 7, so they are the same. So we have one of them here, becoming 2 a to the power 7 over 3. So now let's look at this term here. What do we get? If we add them, we are going to get minus 4, taking minus 2 over 5 plus minus 2 over 5 gives us minus 4 over 5 a to the power 7. And we have a to the power 7 over 7 here, a to the power 7 over 7 here. Adding their coefficient 1 over 7 plus 1 over 7 is going to give us 2 over 7. It's more like we have one of them here and one of them here, so 2 of them. 2 of a to the power 7 over 7. They equal 1. Now the next thing we want to do is to factor a to the power 7 out, since it is a common term here. So we are going to have n to the power 2, a to the power 7. Factoring a to the power 7 out, this place remains 2 over 3, and this place becomes minus 4 over 5, and this place becomes plus 2 over 7, since we factored a to the power 7 out here, so equal 1. So let's add the whole thing here. That is going to give us 16 over 105. So n to the power 2, a to the power 7, multiplying 16 over 105 equal 1. So now let's multiply both sides by 105, so that 105 will take care of 105 here. So we are left with 2n to the power 2, a to the power 7, multiplying 16 equal 105. So let's divide both sides by 16a to the power 7. So 16a to the power 7. This will get rid of that. And then we are going to get n squared equal 105 all over 16a to the power 7. Taking square root of it will cancel out the square root sign, and our n, normalization constant, is going to be 105 all over 16a to the power 7 all square root. So the question is asking us to calculate for the normalization constant. And in this case, we've calculated our normalization constant to be n equals square root of 105 over 16a to the power 7. So we can therefore go ahead and write our normalized wave function as, that is, if we are asked to do so, or we can a to the power 7, then x multiplying to bracket a to the power 2 minus x squared. So this is a normalized wave function. So since this wave function is normalized, it should be able to explain probability, give us a probability of 100%, not a probability of 90% or a probability of 120% or a probability of negative 50% of describing the presence of a particle in space. So that is the main idea behind this whole thing. If you found this video helpful, kindly subscribe to my channel and give a thumbs up to this video for more educational content like this. You can also refer my channel to your friends. Thank you. Bye.